There, YouTube and Twitch. As the title says, this is going to be a laid-back stream, and probably a short one because I'll have to do some cooking very soon. But I got super excited because I think I when I got home from work and had rested a bit, I decided to open Visual Studio and just do a bit of Googling in terms of how to be certain that the bugs that I had fixed were certainly fixed, and there were no stone unturned in terms of figuring out whether I needed to do more work on the algorithms. And I did a Google search like this, add vector to quaternion, and I think I found let's see, 3D vector to quaternion. No, that's not it. But somewhere on Stack Overflow slash um, um, slash Stack Exchange, there was an answer that that underpinned the whole concept of quaternions not being commutative. And I wanted to make sure that inside my math function that I multiply the quaternions in the right order, besides the actual changes to the algorithm, which I originally derived from DirectX math, the DirectX math library, but it didn't give me the right results, and it's my own adaptation, so there might be bugs in it, but I used a known algorithm, and yeah, I updated the multiplication of the quaternions here, and then I figured out that this was supposed to be in the opposite order. The old one was here, the new one is here, and since I did that, the last few bugs that I had yesterday were fixed. As you can see here, we have Paul hanging out on the floor. Whenever I lift Paul and drop him, he wobbles a bit around. Whenever I slam Paul into the wall, he drops down and falls flat on the floor, which is great because it's basically what I wanted to see. And as you can see, Paul even does a small bounce here. I can probably adjust that. Let's see. No, the pushing algorithm doesn't work right now. It's not powerful enough. Let me see. Let's shove him a bit. Let's increase the force behind the push method. So we can push Paul, and he rotates beautifully until he drops down on his face. Yeah, it's a powerful push I do, so I'm quite certain that this is intended behavior. Of course, when he spins, it's whenever I'm using the algorithm. Right now, I'm using 2 buttons to elevate him and push him into the wall. And a powerful push to him makes him fly off the ground. And as you can see, it simply just works, which means that after exactly, or perhaps I should say approximately 1 month of work, I've implemented not 1, but 2 different physics systems. And I've arrived at a point which I sometimes didn't ever think I'd get to, where the physics engine seems to be working. There will of course be new bugs in the future. Right, Paul? Let's see. Okay, that's not the button I used. Can't remember the controls for the free floating camera. It's been too long. But yeah, that is where we're at, and it feels pretty good to say the least. So you might say, what's next? Well, there are a lot of improvements to the whole physics system that needs to be implemented. Let me just clean up some of this code here. Let's see. Let's do a scope for all of the debugging. There we go. And let's do physics simulation. Let's see. We have our penetration resolution, giggity, and our, I don't think we need to do that, even though no, it doesn't matter. Yeah, so I don't think we need to do that either. Let's see, do we get any bugs? I don't think so. No, I don't think so. Yeah, the pushing effect is not great. Yeah, it still works, so we don't need that. These 2 flags here are going to go away whenever I implement a sort of API for the physics system. Right now it's just, let's see, some code here. Let's remove that, remove that. Great stuff. And we don't want to do that. This will also be removed. Can I remove it already? I'm not sure. Probably could. End of physics. So yeah, I mean, I don't know what to say other than this is awesome. Let's put Paul back in a standing position. Great stuff, Paul. Let's see. Okay, you simply just fall flat on your face. We have a small bit of vibration. We could fix that by doing some optimization. We have different testing presets here for the orientation of Paul. Yeah, but we have physics. So let's see if we do. Whoops. I'm not used to using Firefox. There we go. So if we go into our Trello thingy here, game mechanics, we have a sort of player capsule already. I didn't really wing that off. Simulation features, rigid body dynamics, collision resolution. Well, more generalized methods, SAT, and vertex clipping. Uh, Interactions between multiple dynamic and static objects. Physics API. We need to do that in the future. We need to do implement sphere and OBB, ABB fully, create broad face system. Yeah, so there's a lot of different stuff we need to do now that everything is actually working. But yeah, it feels good to know that everything works as it should. Right now, because that means that instead of trying to work out how the basic systems are supposed to work, we have a sort of structure for the whole thing that can be expanded upon and uh, be more generalized uh, so that the system can handle a lot of different cases and a lot of different interactions. That also means that we can plan out our data structures way better. Um, yeah, so yeah, we will do some optimization stuff later on. Depending on how complex the system gets, I might even do a bit of multi-threading work. Our whole system design is kind of set up in a way that is fairly easy to um, uh, set up for parallel processing. I mean, um, we could chunk contacts and um, use threads and SIMD operations to process contacts in parallel, and We could, for instance, do synchronizations around the update part of the code if we wanted to. We could do pre-calculations, pre-compilations of the required information. Yeah, we could do all sorts of different parallelization schemes. I'm sorry, that's an awful word. Uh, um, yeah, as you can see here, I generally structure the program in a procedural data-driven way, which means that data, the whole idea of a data-oriented design is you prepare data, you process data, and you output data, and you repeat. Which means that you can prepare your data or structure it in such a way that, for one, it's highly cache effective, and second is really easy to chunk, um, which also means that uh, uh, you can run it on multiple threads without much need for different kinds of synchronization points. And lastly, you can do a lot of SIMD programming where you take a lot of data and depending on which architecture you're programming with in mind, you can kind of arrange the data. So as I've mentioned, it's preferable for the to avoid cache misses, and you can also handle a lot of data simultaneously. So um, when I say we will build out an API for the physics system, it will basically just be a somewhat empty I don't know even if it's gonna have a physics class. Maybe I'll just do it procedurally, and just kind of use namespaces to separate different parts of the code structure from each other. The code will end up being a really C style, I think, but that's not a bad thing. At times I kind of contemplate rewriting the whole thing in C instead of C++, but yeah. I guess C++ has some very nice features and classes aren't that useless. I mean, just because they suck at handling performance critical parts of the code, I guess you could structure your API in it. I mean, DirectX12 is, at least in the C++ version, built up around classes. Yeah. But anyway, that's the overall idea. These things will get split into some functions that handle different parts of the computations for when we decide to handle multiple objects. Yeah, so there's, even though it works and everything is totally awesome, um, there's a lot of work to be done. We want to support, whoops. Yeah, okay, that's an edge case. It's supposed to bug out right there because it can't handle collisions edge by edge, for instance. Yeah. Uh, but that's what I've been blabbering on about for about 15 minutes now. We have to build a generalizable, robust system. Yeah, So we have some stuff here. Can I actually add sub goals for this? I'm unsure. Let's see, let's see. Let's see, let's see, let's see. All right. Yeah. If you have any suggestions in terms of features that we should implement here, point-based pipeline, yeah, we did. Kinda. Well, particle pipeline, no. Yeah, we did. We might look into handling particles only on the GPU. Yeah. Let's see, modeling. We still need some more models. Oh, I still need to create the damn. Just fucking do it. Oh, I'm sorry. Shouldn't be swearing. Bug fixes. Yeah, we need to do some different stuff here. Debug help us. Rendering planes. Rendering points. Yeah, we did that. Uh, physics, collisions. And we need some. We also need to start doing some UI, and we need to do some tools. And these kind of overlap. Oh, a HUD. Already. Yeah, a HUD. That's a project I wanted to do a long time ago. Yeah. Anyway. I think the scope of this video really just was me wanting to celebrate with you guys that I think we ended up at a really good spot here. It's been almost 2 months, or rather, it's been more than 2 months since I started this project. 2 months and a couple of days, and I've spent almost a month on the whole physics part of this system. And I must say, yeah, physics are hard, man. It's great that I stuck with it. It sucks that the debugging is so hard, but yeah, I definitely learned a lot. I mean, some general advice if you try to do implementations like this yourself, or if you're perhaps watching this in the future and yeah, uh, trying to, in quotes, code along. This is not exactly an elaborate tutorial, even though during live streaming I always am interested in uh, showing parts of the code. Yeah, I think the general advice would be always design sort of unit tests for your different methods, and do not just assume that uh, your method um, produces the correct result. Uh, if you can, try to give it certain test inputs that um, you know kind of should produce the same result each time, and then uh, check whether you are able to produce the correct results, and then change the input scenario and verify that the results you get from the new inputs are still uh, correct. Um, and be sure you have a way of debugging stuff. For me, it really helps to visualize stuff. So be sure to use a renderer where you can debug things efficiently. Uh, I write my own renderer. So yeah, that means that um, so yeah, that means that everything is kind of up to me anyway. Um, yeah, if you find any of my streams helpful, inspirational, perhaps helping you to persevere, maybe you find it soothing that someone could waste a month's worth of spare time trying to hunt down a bug that they kind of created a long time ago. Feel free to comment, like, or subscribe, follow on Twitch, drop by the stream, or interact. Um, you're also welcome to support the channel. Um, yeah. Yeah, we're definitely at a place where the stream can be happening more regularly again, since I'm not messing around with the um, detective work of snuffing out serious bugs that I don't know uh, where is located, where are located. Yeah. So I think I have some obligations at my job, which will hamper my streaming schedule a bit, but things should be more straightforward in terms of just doing uh, uh, live coding sessions. Since, yeah, I'll do actual coding, not just trying to do bug fixes. Um, yeah, all right. Yeah, I've been blabbering on for a while now without doing anything in particular. So we will just have one last look at Paul in all his glory, and we will make him hover, and we will smack him into the wall. Oh, okay, okay, okay. Does he fall over? He's, yeah, okay. He had a bit of friction going against the wall, but we kinda defeated Paul. All right. Thanks for dropping by. Hopefully I'll be seeing you around on the stream. Have a great one, and keep it chill.